Alright, section 4.4 is on the Pythagorean theorem. The objective is to use the Pythagorean theorem to find the missing side in a right triangle. So a right triangle is a triangle that has a right angle, which we've learned earlier in the chapter. The legs are the sides that form the right angle. The hypotenuse is the side opposite of the right angle. So what I typically do is when I have a right angle, I draw an arrow across, and that is going to give me my hypotenuse. So name the legs and the hypotenuse of the triangle below. So the legs are going to be the ones that form the right angle. Okay, so that would be right there. So xy and xz. The hypotenuse is directly across from the right angle. So that would be zy. So the Pythagorean theorem, it's used to find the missing side of a right triangle. So it's one leg squared plus the other leg squared equals the hypotenuse squared. Or a squared plus b squared equals c squared. That's our key. So find the unknown side and round to the nearest tenth when necessary. What I do first is identify the c. Always, always, always. Because that's my most important. Then we're given our a. So we're looking for a. We're given a b. So then we just plug it in our formula. So our a is unknown. Our b is 6. And our c is 10. So a squared plus b squared equals c squared. So a squared plus 36 equals 100. Okay, so then we'll solve from there. Make sure you square root everything before you start adding and subtracting from each side. So 36 minus 36 each side. So a squared is equal to 64. Square root. So a is equal to 8. Alright, so first, our c actually is what we're looking for. There's our c. We're given our a and our b. Now your a and b can be intertwined. It doesn't matter which one you have as a and which one you have as b. Alright, so 8 squared plus 7 squared equals c squared. So 64 plus 49 equals c squared. So 113 is equal to c squared. Then to get rid of that square root, you got to square root each side. So square root of 113, 10.6. So c is equal to 10.6. Alright. So directly across from the right angle is our c value. That's 14. We're looking for b, so 7 must be our a. So 7 squared plus b squared equals 14 squared. So 49 plus b squared equals 196. Okay, now we subtract from each side. So minus 49. So b squared is equal to 147. To get rid of the square, the b squared, just to get b by itself, we have to take the square root. So 12.1. So b is equal to 12.1. Now, to check to see if you're right, what you can do, you always want the hypotenuse or the c to be the biggest number. So 14 is bigger than 12.1. So we could assume that our answer is probably correct. Alright, we're going to skip that one. Alright, the Pythagorean triple is a set of 3 positive numbers, a, b, and c, that satisfy a squared plus b squared equals c squared. And these are 5 that are common. Okay? So it just means that the number is never going to come out to be a decimal. It's always a whole number. So find the length of the hypotenuse and tell whether the sides form a Pythagorean triple. So we're looking for the C. We'll call this our A and this our B. So 8 squared plus 15 squared equals C squared. So 64 plus 225 equals C squared. So 289 is equal to C squared. Now we got to take the square root of each side. Do not forget that step. And our answer, C, is equal to 17. Now we have 17, 15, and 8. All of those are whole numbers, so yes, it does form a Pythagorean triple. Alright, what did we learn today? Today we learned about the Pythagorean theorem. Okay, if you have any questions, put it there, and then a sample test question could be making a triangle and putting 10, 5, and B, and solve for B.